Hello, yes, welcome back to Secure Tech with JKE. I'm John. Let me keep it simple today. Before we touch a single command today, in my last video, I promised that this is a 6-part video series and that the second video to 6th video is going to be hands-on lab that demonstrated what I highlighted in video 1, the first video in this series. Okay, so before we touch a single command today, I want to give you a number, 47. That is the number of MCP servers or server instances a 2,000 employee European bank found when they run an audit of their environment. 47 servers, none of them on its IT inventory. Several of them had production database credentials wired directly into their configuration files. Not staging credentials, production. Yeah, you hear that. And this was not a startup moving fast and breaking things. This was a regulated financial institution, audited annually. The server existed because developers were solving real problems. A couple of engineers installed a Postgres MCP and GitHub MCP at an hackathon because it made debugging faster. They told their teams 6 weeks later, 14 engineers were running it. Someone added the config to an environment template. It spread through repository clones. Someone added an MCP server step to CI pipeline. It shipped in every build from that point forward. Nobody made a rollout decision. Nobody kept a list. That is how you get to 47. This is my lab 1 environment. This is the risk description of my lab 1, this video. That is what it will take care of. We are so in this scenario, in this use case, we are covering MCP 09. That is one of the top 10 for MCP servers. Shadow MCP servers. Then MCP 01, token management, and secret exposure. These two belongs together because the first thing you find when you discover a shadow server is usually a hard-coded credential inside it. Yeah, it doesn't just start with MCP server, but it's just that MCP server amplified because it's like an agent. Now, let's look at the shadow MCP server. Let me be precise about what makes this risk dangerous. Every other risk in the OWASP MCP top 10 assume you know what you are defending. You know your MCP server exists. You know what they connect to. You are trying to secure something you can see. MCP 09 breaks that assumption before any other controls matters, before you rotate credentials, before you harden permission, before you add login, you need to know what is running. Yes. The Gravity survey from February 2026, 750 US and UK enterprises found 3 million AI agents in operation. 47% of them unmonitored. That is 1.5 million agents effectively going unseen in mainstream enterprise right now. And 88% of those organizations experienced or suspected an AI agent related incident in the last 12 months. Your MCP server count is not 0. It's unknown. Yes. So if you think we don't have MCP server in our environment, no, it's just because you don't know. Until you run these commands, that I will be showing you in this lab, you might not know. So yes, so MCP 09 and 01 will be our focus point in this lab 1. Shadow servers, exposed credentials. These are the things we want to make sure that you can get to work the next day and have something you can do in your environment to make sure that you begin to build a program and workflow around your MCP, estate that is considered secured. So let me just do quickly with token management. The reason I pair these two risks together is simple. Every time you find a shadow MCP server in the world, the first thing inside it is usually a hard-coded credentials. Here is why. When a developer spins up an MCP server quickly at an hackathon for a prototype to test an idea, they take the default and wire in the credentials directly. Environment variables in the config file, token pasted into command line. The plan is always to harden it later. Later does not always come. So the critical principle for MCP 01 is this. If a token reaches the LLM context, treat it as already leaked. So the model memory is not a vault. It is not encrypted at rest in any meaningful way. From the agent's perspective, 2 responses that contain credentials get summarized, passed around, included in subsequent calls. Logs capture the full context, including any secret that appeared in it. And unlike a traditional app where a leaked credential requires an attacker to find and extract, here the agent itself may helpfully surface it in a response. Okay, let me show you what this look like in practice. So let's get started. So the first thing I want to look at is to create an environment. You can see my development environment right now. So let me just create some file structure and I can cd to lab 1 and do ls. So I have 3 project files here. We have project alpha, project beta, I'm Project Gamer. So that is how I want my environment to look like. Now, the first thing I want us to do is to create, in the project alpha, I want us to create an MCP with hard-coded token. So let me quickly do that very quickly. I want us to do it in such a way that it will be very, very interactive. So that is for project alpha. Then I will do project beta. I'll make all this available. Now this is the hands-on for that is hands-on for our video 2. So it's just continuation, and I will do project gamer. So okay, so now we have these 3 files. Now the first file is, let me be clear, the first file is to simulate an environment where you can have an MCP JSON file that has some tokens in there. So the second one is to have CI pipeline, like workflow, where you have keys, API keys within it. And the third one is using different file names, like you want to disguise that MCP server as if it's not actually MCP server. So these are the 3 scenarios I'm creating here. And what do we want to achieve with this is to prove to you, is to show you how tokenization, token management, and shadow MCP server kind of, go under the radar, and what you need to do to fix that in your environment. So now that that is done, then I want to show you my directory tree. So if I do 1 sec, I think I might be needing some, okay, okay. So let me just show you my directory, and yeah, so if you look at my directory there, you should be able to see what is going on. So where's my directory? Just want to show you my directory. Okay, so you see, so this is my directory. You can see here that you have project alpha, I have MCP.json. In the beta, I have the deploy workflow in my GitHub actions, and I have project gamer, I have my cloud desktop config JSON. So it's just a way of disguising that as if it's not something that has to do with that. So what do I do next? Now that I've created an environment, a vulnerable environment that depicts what these situations or scenarios are in your environment, then the next thing is to detect them. So let's assume you have this kind of files laying around in your CI/CD environment, or maybe your code bases. What do you do? Now we've simulated that here. What do we do? So the first thing is for you to try to use the find, like our Linux command. So these are the things you can begin to do in your environment right away. It might look like low-hanging fruit, but that's the starting point. So if you look at it now, it returns like 2 directory files where you can find hard-coded tokens. Returns that. So then you can use grep as well. You can use grep here. You can see it's showing the same thing, and I think there's something missing there. It doesn't show the cloud desktop config file. I think somehow it was able to evade that. So the other thing is now find hard-coded credentials. So let's look at this another thing, because we've been looking for the file location. Now you can do this. So you can see Wella. You see, these are hard-coded credentials. I kind of put some fake ones there, just to simulate this environment. But if you have the real one, this is going to show it, right? So you can see AWS key ID, you can see secret, you can see GitHub tokens, Anthropic API keys, and stuff like that. So you see all of them. So you can begin to do this. How do you do this? You can pull down your code repos, in your local environment, begin to search them, begin to see what is going on. You can use API too to search directly, but that may consume a lot of resources in your environment. I don't know, but this is the safest size, just for you to know. Because one thing I want to make very clear here, the reason why I'm going the old way is just for us to understand the concept. Before you automate anything, before you create an agent to do that, understand what this process is. That is why I want to go. I don't just want to wrap up some script and no. I want to go one by one for everybody to see this is how it should be done. Then when you understand the process and the consequences, the output, the result, then you can begin to automate them. So that is done. Then the other thing is that we can extract just the key alone, by using our famous Linux command like cat. And let me clean this up. So we can cut it. And you can see the key, just the key alone. So we can see that. Okay. So then the other one is another step for us to detect, scan for services on MCP ports. So there are non-MCP ports. What about you scanning for them to see whether they are active in your environment? If they are active, you will know that something is going on. So there's nothing going on here. I scan for 3000, 3001, 8000, 8080, 8765 and 9000. All of them, they are not nothing. So that shows that there is no MCP server running in my environment, right? So let's use Nmap also. So if you look at it, almost the same thing, but you get more information. Talking about all those port numbers, all of them are closed. Nexus, this one is all of them are closed. So none of them is open. That is also a way of you understanding your environment. Okay, then let's look at how do we move these credentials out of config file. How do we move it? Now, first method is you can create .env file. For instance, if I modify my current configuration and I kind of put it on in .env. So after doing that, if I check again, if I check the same thing again, so create the clean MCP file. Now let me create a clean one. So what I'm going to do here is that mcp.json now, I'm going to recreate the one I had before. So if I recreate that, I think that is not going well. I have some issues there. So now, I created a new mcp.json file here. Now, this time around, if you look at it, you see that the token, GitHub token is gone. It's not in this environment. It's not hardcoded anymore. If you look at the Postgre URL, it's not hardcoded anymore here. So that is gone. Now, what is it I want to achieve here is to show you that you can use .env file hidden somewhere to capture your credentials and tokens while you reference them in your config file. Classic, software engineering practices. I don't know, something to call it again. So now if you try to now add .env to git ignore. So if you want to make sure that a particular file is not committed upstream, so you do this, you add that file .env to git ignore, which will never get committed to GitHub or GitLab upstream. So if I do this, that shows that even if I commit that, it doesn't work. Yeah. So then I can make more of a white card to just be on the safer side. So I have that too. Anything that start with anything but end with .env. Okay, so this is that. Now that shows that I'll be able to fix a problem of committing or maybe hard coding or wiring secret into MCP or MCP server configuration. That is one method. Another method, you can use Vault. I think I created another lab that uses Vault, but that is not the focus of this video. So create an MCP server registry now. That is the next thing. You take care of the tokens, hardcoded, hardwired. Then you want to know how many servers do you have in your environment. But before we do that, let's verify the clean config has no hardcoded values. So let me just grep it again. So you see it doesn't have that anymore. You can see that it doesn't have that anymore. So instead of having the the tokens immediately after it's just variable name that is coming in here. So that's good. Okay. So let's look at the server registry now. Now I will create let me simulate something here that we can work with. So let me create a server registry. So that is done. Then write a simple check script that compares fund servers to the registry. So now when you search for servers, you want to know whether that server is in your registry or not, because already now you have a registry of all your MCP servers. So when you have them now, because in your process, in your workflow, one of the things I will advise is that you can make this process automated, and maybe you want to be running it weekly or monthly for you to know what is going on. Maybe people are creating all these shadow servers, MCP servers, or hard coding credentials and tokens into your code base. Then you want to have this process automated and maybe run as a background job or maybe as an agent, whatever you like, that will be running on cadence. And if there is anything detected, now this is where this is good. When something is detected, try to check it against your registry to know whether it's already recognized and eventualized in your registry. So that is what I want to do. You have another Python script here that you can use in doing that. Okay, it's a long one. Okay, so let me do that here. Okay, so we'll create that check. So when that one is checked, it's gone. I think there's an error there. So we can do that again. Okay, so that check is created now. It's a Python script that check that for us. Then when we now, I think we can do a quick check and okay, quick check. So if you look at it now, it tells you that fund config project alpha MCP JSON is in this case that is in the registry. The other ones, servers, MCP servers, they are not in the registry. All those ones you see that cross out, not in registry, kind of pick them. If you go through the script, you see what I did there. So pick them and make sure that, okay, they are not in registry. So if you have this kind of information, that when that background job run and send you this kind of information, maybe to your Slack or maybe to any visibility tooling you have, it's like every week or every month, whatever works for your environment. I think it's a good starting point, whereby you'll be sure that, okay, if there is anything going on, slipping in under the radar, you have a process that captures that and let you know. Okay, now how do you fix that? So fix 3, verify rerun detection after cleanup. So let me see now. Let me use my grep now to see if this will still bring some result. Nothing. So no output, credential removed from the config file. So now if you look at this, that shows that there's no credential in our config file anymore. Credentials are moved to .env. From .env is added to git ignore, and then we have a registry of all the MCP server we have in our environment, and we have another check process that checks to see if there is anything that suffice or that surface without being registered. So now, if you look at this at the beginning, 2 things we want to achieve here. One is to take care of token mismanagement. The other thing is to take care of shadow MCP server. These are 2 OWASP top 10 that I promise that this video will take care of, and it has taken care of it. 1, token mismanagement, hardcoding token into your code base that can eventually be used at scale, amplified by your LLM or your agents. And the other one is having unmanaged, ungoverned MCP server. And if you look at this lab, it has taken care of the 2. And with that, I come to the end of this video. And the next one, join me on next one. Once again, my name is John Kayode Abisi. This is Secure Tech with JKE.